Understanding how humans manipulate objects is key to robotic automation of daily tasks. However, collecting dense 3D data is a tedious process, which occlusions make even more challenging. Recent datasets that strive to capture ground truth hand annotations from videos in the presence of object occlusions rely on hybrid approaches. Noisy annotations are obtained automatically, and manual verification is performed to ensure their quality. These automatic annotation methods do not scale to the diverse and large-scale data typically required by modern CNN methods to obtain high accuracy in unconstrained settings. In this work, we investigate hand-object reconstruction from a sparse set of annotated keyframes, aiming to drastically reduce the number of frames for which ground truth is required. In order to study the impact of annotation scarcity, we train our model on subsets of the training data. Little degradation is observed when using down to 20% of the total frames. However, below 10%, generalization is severely affected by the lack of training data. Our goal is to leverage visual similarities across neighboring frames to provide additional guidance for hand-object reconstruction. We introduce a lightweight model for joint hand-object pose estimation and demonstrate its state-of-the-art performance on two recent manipulation datasets. Our model relies on known object meshes and a parametric hand model. It allows us to recover the final meshes in a single, fully differentiable forward pass given the input image. Given an unannotated frame with noisy prediction, we recover the closest annotated frame. For the annotated image, we assume that the ground truth 3D pose is known. As the prediction and the ground truth meshes are available in camera coordinates, we can explicitly model vertex displacements in the image plane. Here, we show the displacement of a selected number of vertices using colored arrows. We use a differentiable renderer to estimate pixel-level 2D displacements between the two frames. Note that using a renderer allows to explicitly take into account mutual and self-occlusions. Using the computed optical flow, we can differentiably warp the annotated image and compare it to the unannotated one. In addition to the ground truth supervision on the sparse annotated frames, we supervise the intermediate frames with photometric consistency. When using less than 1% of fully supervised data, training with the additional consistency term improves object and hand poses quantitatively at test time. Qualitatively, we observe that the model fine-tuned with photometric consistency is able to correctly predict a wider range of object poses. It also predicts more accurate hand poses in cases where the baseline prediction only partially overlaps with the visible hand in the image. However, our color-based loss sometimes doesn't provide improvements in cases of severe motion blur or when the hand and the object are strongly occluded by the person's body. We observe that the model trained with photometric consistency produces more stable results over time, even in cases of fast motions, when the baseline model often fails. When using 2.5% of the fully supervised data, while both models predict more accurate poses, we observe consistent improvements in hand and object poses over the baseline.